We're going to cover the fundamentals in a lecture style of the application that you built earlier in this module. So just to recap what the Flet application does, we have a local llama, so it's a local server, and we can ask Corey some questions. What's a good burrito joint? And Corey's in his mid-20s, and he's talking with the language, the diction of a mid-20s person in San Francisco. And he knows about San Francisco since he grew up there. And it's coming across as a set of streams. Because the Flet app has a UI to it, you have to deal with both the UI and the underlying logic when you build this type of UI application. But it's very similar to the command line. In the Flet UI version, we do create the async IO task for the stream response. And we talk to the Ollama server with httpx. AsyncClient is the same as the command line app. We're using the async keyword here with as for the Python for the context manager. And it's a stream. So this stream is from httpx. Right? So this client is this client right here. And the easier use of async communication with Fast API and the different interfaces for it is the primary reason we did move away from Django. And although it is possible to build asynchronous UIs with Django, it's definitely possible. We were having a more difficult time since the underlying technology started off as synchronous. So in the traditional approach, you have a message that's sent to the LLM, and you wait for the response to complete, and then the screen, or in the case of a web-based application, it will update. With a streaming approach, the tokens appear one at a time, and you want the UIs to still be responsive during this time period here. In the top section, you could, without it streaming, you could have the UI be responsive, but then you still need to make it asynchronous to show some spinners or something. And it's probably better just to have the words appear one after the other. Since the person is viewing the screen, they have something to do, so it doesn't feel like they're waiting 5 seconds or 10 seconds, even if the actual response does take that amount of time. It definitely is simpler if you use synchronous communication, and this is probably better to start with if you just want to get some type of response back from the UI. You can also shorten this down with a bunch of properties that's sent to the Ollama server to reduce the amount of text that's sent back to you. Most likely, you will want to make it asynchronous to provide a more delightful user experience. You will need to use the async keywords, and you can tell that in this case there are a lot of the async keywords. If any portion inside here is blocking with a synchronous connection, the entire thing will be blocked. Also, instead of httpx.client, there is the keyword async client, so the async one is different. Down here, response dot, there's a asynchronous iterate lines. At a simple level, if you're discussing this on an interview or something, the asynchronous function definition, you just put the keyword async in front of the function. So this part is pretty simple. And then if you want to wait for something to complete, such as maybe getting the chunk from the internet or the server, or you need to get a file that's been read, or some type of data response, you put a wait in front of that function, and it will wait for within that one thread. It's going to wait for it to get the information that you need, such as a chunk or a file I/O operation or a network operation. You can practice simulating it with a simple sleep. Notice that there is async IO. This is a package that you import at the top of your program. It's called async IO in Python. And you can sleep it with asynchronous IO sleep so that it just blocks it on this one. The request package is very famous, quite old. It's been around for a long time. It's very comfortable to use it. Most of the examples are with requests. httpx is a replacement for requests. It's a different project. It does add asynchronous capability to it. And so, although you've probably used requests in the past, most of the tutorials about Python are using requests. It is a synchronous request mechanism, and it's going to block the execution. It's not usable within the asynchronous applications in the style that we are writing. Although there's many packages for asynchronous HTTP communication, one of the more famous ones, possibly the most popular, is httpx in Python. We've covered this pattern, async, so it's with, this is a standard Python, the with as. This is a context manager which handles the opening of the stream, execution of the code under this block here, as well as closing the stream. In the Ollama API, it's pretty simple to enable streaming. This is just a Boolean variable. So we'll just set up the stream to true, and it'll suddenly start streaming. The bigger challenge is dealing with the stream response. So it's coming across as a set of chunks. You're not going to get the entire text that you want to display within your application. You're going to get it one chunk at a time. A chunk could be a word, or it could be a portion of a word, it could be a character. And you have to check to see if the stream is done if you're going to be using more complex applications. We didn't do this in our simplified application, but it's relatively simple, right? You just check to see whether done is true. So this pattern is going to occur again and again. There is a async. There's with, which is standard Python for the context, and then it's going to open up some type of client here, and we'll put the handle as client. Then you actually set up the stream here with the HTTPX. Post is the protocol. You might be more familiar with GET as well. And then this is URL which we set up, which is the Ollama endpoint. And there's the data that we sent for the different options for the Ollama server, including the model. Once we get the stream going, you're going to have to iterate through the lines. So line is the variable that we create. So it's somewhat simple, right? For variable in, and then there's something here, right? What the thing here is, it's a set of lines that you can iterate over. This is from httpx. You can refer to the documentation. The A here stands for asynchronous. There's also iterate lines, iter underscore lines without the A for synchronous. And then we're converting it over into Python dictionary. So then we can more easily parse it. So this section here converts it, this chunk is going to be a Python dictionary, and then we can easily parse it within Python. Once it's in a Python dictionary, we can then grab the chunk pretty easily. And then we can start putting that chunk or that tokens into this accumulated text. And this is what we're going to use to display it onto the Flet screen. This technique is inefficient in that it's going to redraw the Flet screen, the entirety of it, the entire message every time through the loop. It doesn't just update the new portion of it. So although this technique does work, especially for simpler and shorter pieces of response, it's inefficient, and you want to get a better strategy of how to only update the portion of the screen that is new. In Flet, the contents of the column is called controls. It's a list. So we're using a Python list append command to append to the list the streaming text control, which is a piece of text in this case that is just query. So this is a Flet text. It's a control. And we're appending it to the list of controls that's in the message column. So again, this does work, and it's great to play around with the UI. However, it is quite inefficient. We're going through the lines and each line is a chunk, right? So each line is like a partial word or a full word, maybe a exclamation point, a period, a set of characters. So it's coming in as a stream, and it's coming in pretty quickly. And then we're accumulating the response, so like a word, into this accumulated text. We're just adding it on to the end of it. Then for every time we get a new piece of text, we redisplay the entirety of the entire message onto the screen and update the page. So the entire message is being updated every time, and that's why it's inefficient. When we start the stream, we are placing it on a separate task and using the task manager to coordinate between the two different tasks that we have. We're using the task so that the UI in the foreground can stay responsive. When the user clicks send, send query runs, and it'll add the user message to the UI. It'll temporarily disable the input button so that we can't put multiple queries to the screen. And then it's going to start the stream response task. This stream response will run as a background task, and it's going to create the streaming text control. So the streaming text control is how we're controlling the UI on the front. It opens up the HTTP stream connections. The tokens or the chunks are processed as they arrive in real time, and updates the UI for each token. When the stream completes, it saves the final message and it re-enables the controls. The key pattern is this async and await for async functions. We'll use a async context manager, and we don't have to manually put a line in that says to close the stream and to flush everything. To get each line from an asynchronous stream, we're using A here. So there's an A for async iter underscore lines. This is from httpx. We're also using asynchronous tasks from the asyncio package. This will to create a non-blocking task that's managed by the task manager of asyncio. We can use the error that's built into httpx with these try and accept, which is standard Python. Try and then accept. Then you have the error here, and there's a colon, where you could print out the error and handle other types of things for the UI. For the UI to be usable, you need to remove the failed streaming controls or those elements on the UI that have failed. Then you need to re-enable the buttons and update the message list. We have a simplified state management where we're using a global reference here with a keyword for non-local, which is in Python. With this, we can access the variable that is actually defined outside of the function. So within the method or the function, we can then modify the variable that was defined outside of the function. So in continuing its use with Ollama, it's synchronous. It might take 5 seconds or longer to get a response. We are purposely making the response very, very short for the purpose of the demonstration so that you don't have to wait while you're developing it. Ollama does take a little bit of time to start up, so there may be a couple seconds for Ollama to actually start for the first request as the model loads. So after the first initialization, after the first request, when you're streaming it, the subsequent request response times will take less than a second. The first one will take a couple of seconds because it has to load the model from disk. But after that, it'll be pretty quick, and you can start getting the tokens in much faster.